What's up guys, we just coming back to sets. We continue exploring sets, and today we are going to consider Venn diagrams as a powerful tool. You also can use other tools like listings. You can use just number lines, interval notations as I was shown before. However, I recommend to use Venn diagrams as well, and if it sounds like as really new for you, just make sure you're just be focused on this video, because this video will be very significant. It's going to be a very significant basis for first education, especially if you're going to use Venn diagrams as the tool in order to list all possible events in probability theory or in statistics. All right, so that's why this tool is very number one, I would say. On top of that, of course, you can use other tools like two-dimensional diagrams, two-way tables, other tools to describe events, all possible events, in order to describe sample space. Okay, and if you didn't watch the previous part related to sets, there were basics for sets, I strongly recommend to first return to part 1, where I start explaining what sets are, what proper and improper subsets, about symbols in terminology, and also examples. So make sure you just come back, switch to part 1, and only then just come back here and watch. Alright, so we're gonna represent Venn diagrams. I'm gonna show you how to visualize intersections, how to find where intersections of two or more events, and also this Venn diagram for two events or for two sets can be really more expanded for three. So three events is called, or three sets is found to be very hard for understanding, but however the principle is still the same, and all this knowledge is still applicable to more sets than two. Okay, if you're trying to depict this using Venn diagrams. Alright, so let's get started. Grab your pens, grab your notes, and let's go. So let's say we have a set universe, which we set up as curly brackets. So X is going to be any element of the universe, so that it defines, so this slash line, it means that the following is going to be condition for X. So let's say X as just integers, positive integers, less or equal than 10. So less or equal than 10, and because they're positive, you also need to mention that your X is from, Z plus, which means it's from positive integers. Okay, and closing curly brackets. Okay, so how to illustrate that? Of course, we can, first of all, we can use several tools for that. First of all, we can list. So we just can list elements like we did it before, 1, 2, 3, and up to 10. So that's what is called listing. Okay, but we also can use straight line, number line, in this case number line, X, and we can use interval notation in this case. So we just use discrete data. So here is 0, and we denote like 1, 2, 3, 4, and up to 10. So actually we can use that, but it's not really convenient because there might be many numbers, and this diagram will take like more space. Okay, so that's why we're going to use a bit different. So we are going to use a different instrument for that, what is called Venn diagram. So Venn diagram represents a rectangle. Okay, so that's going to be a rectangle, and within a rectangle, that's this rectangle represents universe, of course. So that's going to be universe, and circle will represent specific subset. It might be proper subset, it might be improper subset of the universe. So that's why if we're required to represent, not S, let's say A, it's better. So let's say A are primes. okay? Primes. But of course you understand that it's not going to be any prime number, but primes within the universe, because we set up universe as positive integers less or equal than 10, so we can list primes only up to 10. So that means prime numbers starting from 2, 3, 5, 7, okay? And that's it, because like other numbers are not prime. So we are going to say that A is a set of prime numbers. And this set we can represent by oval or circle. So possibly it's better to use circles, but it doesn't matter actually. You can use ovals as well. So that means within the context, we put all the numbers within the circle A, because circle A denotes prime numbers within the given context. So it's going to be primes. Too much, sorry. Okay, this is going to be A, and we put all primes 2, 3, 5, and 7. 2, 3, 5, and 7. Okay, but what about other numbers? As you remember, we consider complement, which is A prime. So that means A prime will contains all other numbers that, in addition with A, will arrange universe. So that means, in this case, it's going to be 1, 4, 6, 8, 9, and 10. Okay? That's going to be A prime. And where to put those A prime? Of course, we can arrange another circle, but most of the case, if it's specified like given circles like for primes, there is no need to put another circle. You just simply use a small rectangle somewhere here, and put all those numbers. Or you just don't use anything and you just put something here. Just all those numbers you put here. And you just write or list 1, 4, 6, 8, 9, and 10. Okay? So that's pretty much simple and pretty much intuitive. Okay? So let's consider another example. We have universe, say numbers again up to 10. So we set up the same universe x, so that x from z plus x less or equal than 10. Okay, and let's consider set A, which is set up as with from numbers 2, 3, 5, let's say 7 and 8. Okay, let it be also primes, not a problem. Primes. Okay, and let's consider also the set B containing elements 2 and 7. So first of all, we understand that B is simply a proper subset of A. How to depict this on the diagram? So we use again rectangle, big rectangle for universe. Our universe are elements from 1 to 10, integers, positive integers, and we can put now circle A for primes. That's going to be circle A for primes. So that's going to be A. And what about B? Because B is from A, circle B is going to be inside. Okay? That's going to be circle B. I'll just change the color, let it be red or pink. And we put here set B and put inside just two numbers, 2 and 7. So the rest part, numbers like 3 and 5, are going to be in set A. As you understand, set B is just nested or completely like put inside A. Okay, and the rest part for universe are going to be 1, 4, 6, 8, 9, 10. That's going to be what's outside. All right, so hope you understand, but there is one more case when you have intersection and union. Okay, we're gonna consider it right now. that is going to be complete covering for Venn diagrams. Okay, I just make place more clean, and right now we are going to consider intersection and union. All right, so let's have a look at specific example. I'll put Venn diagram as a rectangle. That's sort of preparation. And let's set up universe as elements from 0 to 10, okay? Again, so that instead of like vertical line, you can also use double points, but okay, so we can set up, instead of putting integers, now we will include 0. That means not necessarily it's positive integers. Neutral, 0 is a neutral number. And we'll say up to 10, okay? But we need to say, mention that x from z in that case. So if you for example, don't mention x from z, so in this case, x might be any real number. So that's why don't forget to use also the type of numbers. So this sort of type of numbers. If you ever encounter with programming, you know, there is the function, lots of function, and if you use a specific embedded function into language, for example, like in C# or Java or any Python, for example, the function will require from you by setting up specific parameters. It will look actually really similar to that. Okay, so for those who are in computer science, we're just going through ICT, I think it's more or less familiar, so, and it's very like familiar for you guys. Okay, so you understand me. And let's set up set A and set B as the phones. For example, let's set A will contain primes 2, 3, 5, and 7, okay, and for example, set B will contain the following numbers: 1, also 3, for example, 6, 7, 8, let be 9, okay. So in this case, how to illustrate A and B and how to show intersection and union. You'll see that. All right. First of all, now I'm going to use ovals in that case. So, maybe like this. Okay, so that's going to be oval for set A. Here's going to be an oval for set B. So we can use in this way, for example. So you see that this is the common part, and this is what is called intersection. So intersection is the place where two or more sets intersect, basically share the common parts. So this is the common. And in terms of elements, you just need to specify which elements are common for A and B. So obviously 3 and 7. There are two common elements. So that's why you exactly put 3 and 7 in the common part. 3 and 7, those two elements. Okay, now you are going to consider only unique elements, which are elements of only set A. In this case, that's going to be 2 and 5. Okay? Next, unique elements for B are going to be 1, 6, 8, and 9. And only 0 and 10 left here outside of the circles, because our set, universe set, is from 0 to 10 integers, but those elements 0 and 10, they don't adhere to sets, either set A or B. So one more time, if we're talking about intersection, we're talking about common parts, and this sign exactly means intersection. Intersection. In other words, intersection basically is the region which two sets shares in common. Basically, in terms of elements, they represent elements common to both sets. Okay, so that means we can denote this intersection through set notation as the following: x, so that's x from A and B. So in this case, 3 and 7, this is intersection. All right, what about union? So union is the region, or basically, yeah, that we used to call the region. So this is the region or specific set which contains elements belonging both to A and B. So to A or B, or both A and B. So that's why we can set up union as the following. So elements x, so that is going to be x from A or from B or from both. Okay, x from B or both. Okay, so using notation, we simply can say that if we have, for example, those two circles or ovals and rectangle, which denotes the universe, so intersection is only the common part. So that's the common part. So A, B, and A intersect with B. This is sort of smile down or smile upside down. And union in this case is going to be everything here, here, and intersection. All right. So in this case, we can define union as everything marked as those like purple violet lines. Okay, so I just use this shading and I need to shade everything, while intersection is going to be just yellow part only here. So that's intersection and this is union. All right, so that's I think enough, except for we can also consider the case where sets A and B don't have any common at all. So in this case, we can consider them as separate circles or separate ovals, A and B. So actually, those sets are called disjoint in this case. So disjoint. If they have no common elements, they don't have any elements in common. If they do have elements in common, they are non-disjoint. So in this case, they're non-disjoint, while here, in this case, they're separate, they don't have any elements. Sorry. So that's why, because they don't have in common, you can always consider A and complement not A as disjoint sets. Okay, so hope it's clear. Please just one more time have a little like review one more time in order to every single like part of this video is in your head, is in your memory, and of course more practicing. So hope you like that. Don't forget to visit my dance channel dedicated to dance. Right now I'm just traveling across Russia, and after that, maybe close to September or maybe October, I'll move into like the rest of the world and be traveling across the world. That's gonna be an interesting story, and maybe on top of that I will arrange some vlog channel for video, travel and dance. Hope it's gonna be very interesting, and for those of you guys who are interested in traveling, so please also join. I'll just share the link later on. But if you're new here and just you on programs like GCSE or A-level, or you just explore in physics as well. I have some materials also. So please subscribe, share these videos, like this video, and don't forget to leave the comments. That was Daniel Dallas, and thanks for watching.